Hey, welcome to 2021, guys. I'm glad you all made it. But I just want to mention that just because that number changes doesn't necessarily mean that, this year is guaranteed to be better. We need to make sure we love each other more. Make sure we bring positivity, we bring understanding, we bring patience, guys. You don't know if today could be your last day or if it could be someone else's last day. Make sure that the last memory somebody could have of you is a positive one. So, with that little bit of heaviness out of the way, if I were to die today, I want you guys to know that I love you and that I'm really excited for you to learn about Chapter 4. Let's go. So, today is going to be a little bit of a review in one way. We're going to be talking about a coordinate plane. That's something we saw a lot of in Chapter 3. That's all about the x-axis and the y-axis, which we talked about. You guys have seen that. Now, we're also going to be talking about relations, not like relationships. Y'all know I couldn't teach you anything about that. I'm a novice. But this is going to be something that's a bit newer. Not new. I think some of us will have seen this before, but newer. So let's get kind of into the business here. We're going to deal with something called the Cartesian plane. All that is, guys, that's the coordinate plane. And describing points and lines. Hey, we did that last chapter. Now we're also going to deal with domain and range. Once again, that's a little bit newer. And how it relates to relations and functions. But before we do any of that, let's review a little bit of vocab. So, coordinate plane. We know that's the name given to the plane that contains the x and y axis. Kind of like we did up here, and in fact, we have one over here. This whole thing is the coordinate plane. Now, within the coordinate plane, it is composed of axes. It's the name given to the two perpendicular lines. We know perpendicular lines have opposite reciprocal slopes. Here's the x, here's the y. That's the horizontal. We sometimes think of it as like a number line, but also the y-axis could be a number line also if you were to turn your paper sideways. Quadrants. This one's going to be a little bit new for some of us. For some of us, it won't be. This is the name given to the four areas divided by the axes. And here's how we can tell. You see we've got quadrant 1, 2, 3, and 4. It forms a C. The quadrants form a C. 1, 2, 3, 4. And we can see that. We know in quadrant 1, your x and y, the coordinates are going to be in the form of x and y. We know that those are going to differ based off what quadrant you're in. If you're in quadrant 1, that's going to be, x is going to be positive, y is going to be positive. Positive, positive. If you're in quadrant 2, we're to the left. That means x is going to be negative, but you're still up on the y-axis, so y will be positive. Quadrant 3, what do we know? You're to the left, so x is negative, and you're down, so y is negative. And then over here, quadrant 4, you're to the right. Okay, that would be positive for x, but you're down on the y-axis. That would be negative for y. That's what we're talking about here, x's and y's. If you're a little confuzzled. So what I want you guys to do is, well, how about this? First, we're going to write an ordered pair, aka the coordinates, same thing, for point R. Well, here's R right here, boom. So R is not to the right or to the left. R is dead in the middle on the x-axis. It's at 0 on the x. And where is it on the y? Up or down? Looks like it's up. 1, 2, 3, 4. Boom. 0, 4. And so we see that will be the coordinates for point R. Now, point R is not in any quadrant. It's not in quadrant 1, 2, 3, or 4. It is on the axis. It's not in a quadrant. If you're curious, point R is not in a quad. It's on the axis. So I want you guys to try writing ordered pairs for point P and point Q, and then name the quadrant. So write ordered pairs for them and then name the quadrant. Go ahead, guys, and try these two. Okay, so point P, we see that we go to the left, 1, 2, 3. So left is going to be negative 3. And then we go down 1, 2. So that'll be negative 2. Now what quadrant is this in? Bottom left, that's quadrant 3. Point Q, we go right, 1, 2, 3, 4. Down 1. And that is in the bottom right, quadrant 4. Nice work, guys. Hopefully you're feeling pretty good about that. So instead of making you guys do all 6 of these, which I don't think you'd have any problem doing if I'm being honest, I'm going to let you guys try 1, 2, 4, and 6. 1, 2, 4, and 6. And once again, you're going to write the ordered pair for each point and then name the quadrant that it's in. 2 things. So go ahead, guys, for these 4. All right, here are our points. Now, how about the quadrants? 1, 1. That's in quadrant 1. Positive, positive, up top right. Negative 3, 4. That would be quadrant 2. Negative 2, negative 3, P, that would be in quadrant 3. And then, in 3, 0, that's on the x-axis. It is not in a quadrant. It is on the x-axis. Okay, last problem of the page, guys. I like this one. Now, I'm going to mark this out. I'm going to say I'm Tom. He plotted the coordinates of his 2 favorite Mexican restaurants. I love Hispanic, especially traditional Hispanic food. The coordinates of restaurant A, I have Casa here. That's not real Mexican food for me. I'm going to go El Tesoro, which is on, it's right off Jarvis. Really, really good little mom and pop spot. So the coordinates of El Tesoro are 4, 7. The coordinates of restaurant B, Speedy Taco, which I like a lot, are in quadrant 2 with the same y coordinate as not Casa, but El Tesoro. So wait a minute. Quadrant 2, same coordinate, y coordinate as El Tesoro. Well, the y coordinate for El Tesoro is 7. So for Speedy Taco, its point, we know the y's got to be the same. Got to be 7. So immediately I can say, okay, A's out. Also, D's out. So I've got B or C. Now here's the thing. Speedy Taco is in quadrant 2. Go back up here. Quadrant 2 is when we go to the left. That's when X is going to be negative. So we know Speedy Taco's X is going to be a negative number. Well, that can't be B. That's on the y-axis, 0, 7. Got to be C. Negative 2, 7. Great, great job. And if you want a visual of this, you can try doing this on paper. So El Tesoro is at, say, 4, 7. We're told Speedy Taco is in the quadrant 2 with the same y coordinate. And if it's in quadrant 2, obviously that's got to be a negative. So there you go. On to the next page. Okay, So this is page 2. And if page 1 was about the coordinate plane, page 2 is about relations. Again, not relationships, although the prefix here is sort of similar. Check out what a relation is. A relation is a pairing of two numbers into one set. So taking two numbers and putting them together into one term. An example could be an ordered pair. Oh, so an ordered pair is an X and a Y. That's a pair that's been brought together into one set. So two numbers put together into one set. I like that. Okay. So now the two numbers are known as, the first one is the domain. So relation is two numbers paired together into one set. First one is domain. The domain is the first number, aka the x coordinate, and sometimes, big word here, we call it the input. So domain is the first number. In this case, x is your domain. It's the input value. Well, guess what? If you have an input value, you're also going to have an output value. And that's going to be, check it out, that's going to be the second number, aka the y coordinate. So your y coordinate is going to be the range. It's your output. And here's 4 ways we can represent relations. These are really good, by the way. Ordered pairs, input, output. There's your input, there's your output, domain, range. So domain, 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 range, 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 range. This table printed terribly, but I think that says 2, 3, 4, maps to 4, negative 1, and 3. Arrows show how to pair each input with an output. How about a table of values? Once again, it's kind of a point, negative 3, 4. 3 goes to negative 1, and 4 goes to negative 1. And then you have a graph. Check it out right here. This point is at negative 3, 4. That's an X, that's a Y. That's your input, that's your output. Same thing over here. That is at 3, negative 1. There's your input, there's your output. Your domain, your range. Domain, range. So what I want us to do, let's look at a couple here. We're given a list of ordered pairs. This is a list of coordinates. We're going to represent this relation by its domain and range. So let's start with the domain. Won't the domain be all of the inputs? Oh, so that would be negative 3, 0, 1, and 2. And we like to list these from least to greatest. So negative 3 is the smallest. 0, by the way, this is called a bracket. It's a fancy thing we can use to list. It helps us list. Negative 3, 0, 1, and 2. Close bracket. It's sort of like a 5 on top of a 2, and then over here it's like a 2 on top of a 5, if that helps. How about the range? Well, that's going to be all your y values. I'm going to do this in blue. That way we can kind of see the difference here. So we got negative 3 maps to 1, that's our output. 0 goes to 2, that's our output. 1 and 1 go together, 2 and 4. So we've got, again, 1, 2. Oh, 1 shows up again. You do not have to list repeats. Don't list repeats. So, hey, 1, 2, 1 shows up again, that's okay. And then 4. Once 1 shows up, you only have to write it 1 time. So that would be our range. I'm going to let you guys try. Try number 2 for me. See what you can do here. All right, let's check it. So the domain are all of our x values, 4, 5, 7, and 5. But because 5 shows up twice, we only have to list it 1 time. And then your range is going to be 6, 1, 2, 2. And you're going to notice I wrote this from least to greatest. So started with 1, 2, 2 shows up twice, and then 6. That's okay. You don't have to write this in perfect order. Perfect, guys. So the last thing I want you to do, this one actually has a little bit of an error. So we're going to jump down to this final problem. We want to learn how to do the inverse. And when we hear that word inverse, we've seen that before. Inverse means when you flip something around. So the inverse means to flip domain and range. In other words, you flip the x and y's. So the x and y's get flipped around. Let's check it out. Express this relation as a set of ordered pairs. So first thing we're going to do is we're going to write this relation as a bunch of points, as coordinates. So our original, let's see, we've got domain is going to be -9 mapping to -6. Boom, that's a coordinate, that's an ordered pair. Then we've got 3 going to -2. I'm sorry, 3 going to -6. Then we've got 5 going to, that is a very fancy 4. We've got 11 going to 8. And then we have 11 going also to 4. So here's a list of ordered pairs. These are commas. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. Now, write the inverse. So the inverse is when the domain and range flip, when the x's and y's flip. So, going to be just like this. -9, -6 becomes -6, -9. 3, -6 becomes -6, 3. 5, 4 becomes 4, 5. 11, 8 becomes 8, 11. And 11, 4 becomes 4, 11. So that would be the inverse. All right, guys. Now, your homework. That's right. We're going to have a little homework section here. Some HDub to do before Wednesday is through. Okay, so you're going to be doing part 1. You're going to notice this homework split up into parts, subheaded there. Part 1 is going to be numbers 1 through 4. You're going to write the ordered pair, and then name the quadrant that each point's in. Part 2, 1 through 3 and number 6. You're going to plot 1, 2, 3, and number 6 on this graph. Part 4, 1, 2, and 4. You're going to determine the domain and range for 1 and for 2. And then on number 4, you're going to use the mapping diagram to create a set of coordinates and then state the domain and range. And so, guys, that will be your homework that needs to be done before Wednesday is over. Thank you very much, and go Jumpers.